Alright guys, now we are going to find the surface area of a cylinder. So cylinders are different because they're kind of like prisms, except for the fact that their bases are actually circles. So we have to kind of approach it a different way because circles are so special in math, okay? So I'm just gonna draw this out. Again, if this confuses you, ignore my explanation part and just use the formula. But I'm gonna pretend, just like my prism here, I'm gonna unfold it kind of and make it flat so we can kind of understand the meaning behind this equation. So if I were to make it flat, I would have two circles, okay? Oh, flat circles in two dimensions, okay? I'd have the top circle, the bottom circle. And if I were to make a cut, okay, from top to bottom somewhere and fold it out, kind of like, you know, the things that wrap a water bottle, the label of a plastic water bottle, how when you unfold it and you just put it flat, it'll make a rectangle. So if I like cut this side and I put it flat, it would make a rectangle, okay? So this formula, 2 pi r squared is my first part, okay? Notice that pi r squared is the area of just a circle, a flat two-dimensional circle, but there are two of them. So we're multiplying the area of each of these circles and adding them together, or taking one and multiplying it by 2 since they're the exact same measurement. So the area of this circle would be pi r squared, and the area of this circle would also be pi r squared. That's why we multiply it by 2, because it's 2 pi r squared, pi r squareds. Okay, so the second part of our equation will correlate to this square here, okay? So remember that the area of a square is length times height, right? So we take the length of the, sorry, not square, rectangle. We take the length of the rectangle and multiply it by the height. And the cylinder gives us the height, okay? The height is 26, but it doesn't really give us the length that it wraps around. So we don't know how long it is. But we do know that if we unfolded this, the length would be the same size as the circumference of the circle. Or if I were to take a string and wrap it around the outer edge of the circle, how long would that string be? That would be the same length as this rectangle. So instead of length, I plug in my equation for circumference, which we didn't practice for the first one, but it was included in your notes for our first lesson. So the equation for the circumference of the circle happens to be 2 pi r squared. Or sorry, 2 pi r. And then we multiply it by the height, which is the height of this rectangle. And that's just kind of the meaning and significance behind these formulas. So again, if that confuses you, ignore it and just watch my example and plug in the values that you know. So let's plug it in. The surface area of a cylinder is equal to 2 times pi times the radius of the circle squared. They're the same measurement. They have the same radius. So that's 11. Plus 2 pi, again, the radius is r, and then the height of the cylinder is 26. Oh, why did I put r in parentheses? I don't have to do that. R times 26. And then I'll just plug that into my calculator. It's really that easy. Oh, sorry, I forgot to square this. Don't forget to square that. Okay, it's pi r squared. Okay, so I end up getting 242 pi plus, oh, r, that's why I put parentheses. R is 11. Okay, now I'm good. So radius is 11, height is 26. Plus 572 pi. Okay, then I just plug it into my calculator and multiply 242 times pi and 572 times pi, and I just add those together. And you should end up getting 255 point, 2,557.26. And we're measuring in yards, and this is area, so it's two-dimensional, so it's squared.